What's up, guys? This is Jahangir from Edporium, and today we're going to be talking about isomers. So isomers are basically molecules that are similar but different at the same time. So to really understand this, we have to talk about our two different isomers. So we're first going to have constitutional and stereoisomers. Now, what makes constitutional isomers special is how they are connected. So they differ in how they are connected. So when we're talking about isomers in general, we're comparing two molecules, and although they're similar in terms of what elements they have, they differ in different traits. Like, for example, with constitutional, they differ in how they're connected. So if we look at example, we can look at something like butane. And butane has a sort of molecular structure as CH3, then we have CH2, we have another CH2, and this is connected to CH3. Now, an isomer of butane, a constitutional isomer, would be 2-methylpropane. And 2-methylpropane would be CH3, then we have a CH, and then that's bonded to a CH3, and we have our final CH3. So as you can see, we still have the same amount of carbons, same amount of hydrogens. Over here in our butane, we have 3 plus 2, which is 5, that's 7, and then that's 10. So over here we have our 3 hydrogens, so you have 1, 2, 6, 9, and then we have 10. So we have 10 hydrogens, and we also have 4 carbons in each of these. So with isomers, we have the same amount of atoms, but we just change in some characteristics. Like, for example, with our constitutional isomers, we're changing in the connectivity, where we're having a linear structure over here in our butane, but we have a sort of branch structure over here with our 2-methylpropane. And as you can see, how they're connected is we have another CH3 that's connected to a CH compared to butane. So with our constitutional isomers, just to summarize, is that we're changing in connectivity. Now, this is different from stereoisomers, and stereoisomers will differ in spatial arrangement. So spatial arrangement, or in their 3D orientation, just to summarize. Now, unlike constitutional isomers, stereoisomers will have the same connectivity. It's just they differ in their spatial arrangement or their 3D orientation. So if we scroll down to talk about our stereoisomers, we're going to have two different stereoisomers. The first one is geometrical. And in this stereoisomer, we're going to have a double bond that restricts the rotation of our molecules, creating cis and trans configurations. So if I scroll down over here just to talk about our geometrical isomers, so we're going to have something like this: cis-2-butane and trans-2-butane. So cis means same side, so we're talking about same side, and trans obviously means different side. So if we're looking at our cis-butane, we have two CH3s that are on both the same side, while trans-2-butane, they're on opposite sides. So this is a geometrical isomer where we're going to have a cis and trans configuration. That's the biggest thing to know about these geometrical isomers, is that we're going to have a cis and transformation. Now, our other stereoisomer that we need to talk about is going to be optical. Now, another word for optical is our enantiomers. So what makes these isomers special is that there are going to be mirror images. So here's an example of our optical isomers, or our enantiomers, where we're going to have an exact mirror image of, for example, D-glyceraldehyde on top and L-glyceraldehyde on the bottom. And this is what makes them enantiomers. They still have the same amount of atoms, like they still have the same amount of OHs, carbons, hydrogens, but what makes them different is their spatial orientation, where we're going to have our OH on top of that carbon and then hydrogen over here, or over here in our D-glyceraldehyde, we are going to have the opposite. So it's just these mirror images that makes them different. So just to summarize, the constitutional isomers are going to be ones that have different connections. So they might have different bonds with different atoms in our molecule, whereas stereoisomers have the exact same connections, pretty much the same bonds, but they differ in their orientation or their position. So hopefully that helps you guys understand isomers, because this is a really big part to understand organic chemistry. And as always, a Pomodoro a day will make you a doctor someday. I'll see you guys in the next one.